Welcome to the solution of our princess challenge with basic Python code. So let's start immediately, and we have 100 princes that hold for the princess hand in marriage, and as a first naive strategy we group the first 50 princes into a test group and the last 50 princes into a select group. So first of all we assign 100 to the variable size applicants, so we have 100 princes here. And we assign to the variable size test group 50, so we have 50 princes in our test group. And let's run the cell here. And before we can start and simulate the random order of princes, we have to first import the random module. And first of all we have to create our 100 princes. So the 100 princes can be ranked by quality from lowest quality, it's 1, to highest quality, 100. So we have to create 100 integers from 1 till 100 with the range function. So let's have a look here at the range object with Shift tab. And here it says return an object that produces a sequence of integers from start inclusive and stop exclusive. So we start here from 1 inclusive, and we want to have all integers until 100 inclusive. So we have to go until 100, and 100 is here the size of applicants. And then plus 1. So then we have here 101 exclusive, so 100 is inclusive already. And let's check and run here. So here we have a range object from 1 inclusive till 101 exclusive, and then we have to create a list by calling here the function list. So here we have all integers from 1 till 100, and then we assign the variable applicant sorted. Alright, and then we can print again our applicant sorted here. So we have integers from 1 till 100. Alright, so and then our princess will date one prince after another, and the sequence or the order is random. So the first prince that the princess dates could be the prince with quality 87 or 23 or whatever. And therefore we have to create a randomly sorted or actually unsorted list with all princes, and we can do this with the function random.sample, and we can pass our sorted list and the size of our random sample. So 100, we want to have all 100 princes in our random sample. So by doing so we are actually creating a unsorted version of our list with all princes. Alright, so let's start, and we have here our random.sample function here. And inside the brackets we are passing our list, so it's applicants sorted. And we are passing the size of our applicants, so we have 100, and let's see what we get here. And you can see here that we get here a unsorted version of our list applicant sorted here. So starting from 11, 5, 9 until 192. And if we run again here the cells, so you should see that we get a different result. So because it's random, so each time we run the cell we get a different result here. So now we are starting with 29, 26. However, we want to create random results that are actually reproducible, and therefore we can use random.seed. So let's try this out here. And we set the random seed to 114, so it could be any number, and yeah, we are just using here 114. And then we are repeating here the creation of our random sample. So let's copy it here, and let's try it again. And here we are starting with 31, 73, and let's run again here, and you can see that we get actually the same random results. So our random numbers generator actually generates here so-called pseudo-random numbers. Alright, so let's store here our results in the variable applicants unsorted. So let's copy it here. And let's print here applicants unsorted. Again, you can see that it starts with 31, 73 and so on. And let's also check the length here of applicants unsorted. So it should be 100, of course. Correct. Now our naive strategy is to slice our group of princes into a test group of 50 princes and into a select group of 50 princes. So let's first of all slice for the first 50 princes, and we can do so here by having here our list applicants unsorted. And then we open a square bracket here. And we have here an ordinary list, so if you want to slice, the 0 indexing applies, and if you want to slice from the first element until the 50th element including, we have to slice here from the first element until the element at index position 50 excluding. So we can simply pass here our variable size test group because it's 50. And let's check this out here. So again here it's starting with the first 50 elements, so 31, 73 and so on. And let's have a check here. Alright, it looks good, and we assign here the variable test group. And let's print here test group. And let's also check the length of the test group. So it should be 50. Alright, this looks quite good here. So our strategy is to have the prince with the highest quality in the test group as the reference prince for our select group, and in our select group we select the very first prince that has a higher quality than the best prince of our test group. And therefore we have to select the best prince in our test group with the function max. So let's try this out here. The maximum of our test group. And in our case here it's the prince with quality 98, and we assign the variable test group best. And let's again print the best of the test group. So now the princess has had dates with all 50 princes in the test group, and she dismissed all princes, but she memorized the best prince in the test group with the quality 98. And now it comes to dating the last 50 princes in the select group, and therefore we have to create the select group. So we have to slice our applicants unsorted list for the last 50 princes. So let's try this out here. And we can simply slice from size test group, which is 50, until the very last. And let's try it out and run the cell here, and we get here in our select group the princes with quality 64, 122 and so on. So it looks good here. So let's assign the variable test group, select group of course. And then let's print the select group. And also check the length of the select group. It should be actually 50. Alright. And again we can see here that the first prince in our select group has the quality 64. Alright, so now we are finished with the first part of our solution, and I hope to see you in the second part. Bye.